The reciprocal is an extremely important concept for solving equations, and it helps out on certain types of problems. So the reciprocal is a little bit different than what we call the inverse, but a lot of times students get reciprocal and inverse mixed up. When you have a reciprocal, reciprocals are two numbers that when multiplied equal 1. And this is an extremely important point. I don't know if you remember me saying it a little while ago, but when I said when you solve equations, you want your coefficient always to be 1. Well, we use the concept of reciprocal to get a 1 as a coefficient in front of a variable. And let me show you what that means in terms of reciprocal first. First off, what's the reciprocal of 1/5? And this will be our example 5. The reciprocal of 1/5 would be 5 over 1. Well, let's test if those actually are reciprocals. And the way you do that is you multiply them. 1 times 5 is 5. 5 times 1 is 5. 5 divided by 5 over 5 is really equal to 1. 1/5 and 5 over 1 are reciprocals. What about if I had negative 1 over 6? What's the reciprocal of that? Well, 6 over 1, and I have to make it negatives, and it doesn't matter if I put the negative up here or down here, but for kicks and giggles we'll make it down there. So negative 1 times 6 is negative 6, and 6 times negative 1 is negative 6. Negative 6 divided by negative 6, well, a negative divided by negative is a positive, and 6 divided by 6 is 1. So the reciprocal of negative 1/6 is negative 6, or negative 6 over 1. What about if I had something like this, example 7, where I want to know what the reciprocal of 1/3 is? I'm sorry, let me say that again. If I want to know what the reciprocal is 3 over 1 is. Well, the reciprocal is 1/3, because when I multiply them I get 3 over 3, which is really 1. The ones that I really want to talk about are the following. That's the explanation of reciprocal, but this is where it really comes in handy. What if I have something like 2 over 5? Well, what's the reciprocal of 2 over 5? 5 over 2. So 2 times 5 is 10. 2 times 5 is 10. 10 over 10 is 1. And then this is the key one right here, because what you're going to see for our coefficients a lot is a fraction in front. And how do you deal with that? Well, there's a really quick and simple way to deal with that. So let's take a look at a problem here. Example 9, and we're going to use reciprocal to solve things. So let's see, I have 1/3 of x is equal to, say, 6. So what's really going on here is I'm multiplying this x by 1 and dividing by 3. Or another way to say it is I'm multiplying by 1/3. Well, what I want is a coefficient of 1 in front of this x, and what I have is a coefficient of 1/3. And it's multiplied by 1/3. So what's the opposite of that? Well, I could divide, but I'm showing you a side trick here, which is to use the reciprocal. So instead of multiplying by 3 and dividing by 1, I'm just going to multiply by the reciprocal of 1/3. And since I do it on one side, I have to do it on the other. So I get really 1 over here, and I'm just left with x, because these just cancel out. And I get 3 over 1 times 6, which is really 3 times 6, or 18. So now I've solved the equation, and now I need to do, of course, the check to make sure I did it right. So now I've got 1 over 3 times x is equal to 6, and I'm telling you that I'm going to plug in 18 for x. So now I've got 1/3 times 18, which is equal to 6, and you end up knowing that 6 is equal to 6, and that is true. So that's how you use reciprocal, and I'm going to give you one more example, and we'll call it a day. Example 10, let's just say I had something like negative 5 over 9 x is equal to 45. Well, I've got a nasty negative fraction here, and it's multiplying the x. It's my coefficient. Well, what if I multiply by the reciprocal, which would be 9 over 5, but I have to make it negative, and it doesn't matter if you make it negative up here or down here, but for kicks and giggles we'll make the 9 negative. But then I have to do the same thing over here, negative 9/5. Key point, key mistake people make is forgetting to bring the negative over on the opposite side. So negative 9/5 times negative 5/9 will cancel out, and I just get x here. Over here I have to multiply through, so let me bring my handy dandy calculator back in. And so what we have here is 45 times 9 equals, and then I'm going to divide it by 5. So my answer is 81. But the question you got to ask yourself, is it positive or negative? And I didn't put any signs in the calculator, but you got to remember that I'm multiplying a positive times a negative, so the answer should be negative. What should I do next? That's correct. Let's check it. The best part of all, because it's where you get the most points. So I rewrite the equation, and I plug in the number I want to plug in. So that's what I do next. And so I've got negative 5/9 times negative 81 is equal to 45. And I'm going to bring that calculator back in because these are getting to be funky numbers, and you really don't want to do too much of this in your head. And I want to show you a couple tricks as to how to do this. What I have here is 5/9 times 81. One way to do this is to start out with typing in 5 divided by 9, and you get a number, and then multiplying that by 81. And we should get 45, and that's great. Another way to do it is to first just say, hey, let's take 5 and make it negative and multiply it by the 81 and then divide by the 9, and you still get your negative 45. So in the end, I'm sorry, it should be positive 45. You get your positive 45. So in the end, and let's just make it look clear, we get 45 is equal to 45, which is true. Oops, not false, but true. Alright, that concludes solving equations for one step, and we'll continue on with multiple step problems in the next few videos, which will be on the same web page as this one.